Imagine a planet so hot that it rains molten iron. Sounds like something out of a science fiction movie, right? But what if I told you that this is actually real? Meet WASP-76b, a distant exoplanet where the unimaginable happens. Have you ever wondered what it would be like to live in a world where metals turn to vapor, only to rain down as liquid iron? Or where the temperature is so extreme that even the toughest materials melt away? Let's dive into this fiery world and explore what makes WASP-76b one of the most mind-blowing planets we've ever discovered. WASP-76b. Let me take you on an incredible journey to a distant corner of the universe, to a planet where the unimaginable becomes reality. Meet WASP-76b, a giant exoplanet about 640 light-years away in the constellation Pisces. Now hold on to your seat because this planet has a feature that will blow your mind. It rains molten iron. Yes, you heard that right, rain made of molten metal. WASP-76b is not like any planet in our solar system, it's an entirely new breed of extreme. Its day side is so intensely hot that it can turn metals like iron into vapor. Think about that for a second. Just the thought of a planet where solid metals become gases is enough to make your head spin. What's even crazier is that this exoplanet's night side is much cooler, and that vaporized iron condenses into droplets, creating what can only be described as a molten iron rainstorm on the cooler side. Isn't that just mind-boggling? When we first discovered this planet, we couldn't have imagined that such extreme conditions existed beyond our own world. This planet is the epitome of a hellish environment, one that challenges everything we thought we knew about the universe and the types of places life could potentially thrive. Ready to dive deeper into this scorching mystery? Let's go! Extreme temperatures. Brace yourselves because the temperature on WASP-76b isn't just hot, it's blistering. On the side facing its star, the temperature soars to a jaw-dropping 2,400 degrees Celsius, which is hotter than the surface of Venus, and even hotter than some parts of the Sun. Imagine a place where metal turns into a vaporous cloud just from the sheer heat. The planet's extreme temperature is a result of its proximity to its host star, making its environment more like an oven than a hospitable place. To put things into perspective, if you were to stand on the day side of WASP-76b, you'd be facing a heat that could easily melt steel, let alone the metal used in construction. This isn't just a casual warm day, this is the kind of heat that would cook anything in an instant. But it doesn't end there. The heat is so intense that it causes elements like iron, magnesium, and silicon to vaporize into gases. These gases then get swept away by the planet's winds carried to the cooler side. The truly fascinating part? That molten metal, which should be solid under normal conditions, becomes part of a strange cosmic weather system. You can't help but marvel at how extreme and wild the universe can get when it pushes the boundaries of temperature to their absolute limits. Tidal locking. Imagine living on a planet where one side is always day and the other side is always night. Welcome to the world of tidal locking, and it's the unique fate of WASP-76b. This exoplanet doesn't spin like Earth does. Instead, it is tidally locked, which means one hemisphere always faces its star, while the other is in complete darkness. Can you imagine what that would be like? On one side, you'd be constantly basking in scorching sunlight, while on the other side, you'd be stuck in eternal darkness, where the temperature plummets to unimaginable lows. This unbalanced division creates two extremes, a blistering hot day side and a freezing cold night side. The lack of rotation gives rise to this severe split, and it's a feature scientists have observed on various exoplanets orbiting distant stars. It's a strange but fascinating phenomenon. The day side of WASP-76b receives an uninterrupted flood of energy from its star, keeping it hot enough to turn metals into vapor. Meanwhile, the night side is deprived of sunlight, causing the temperatures to drop and creating an eerie contrast between the two hemispheres. What's even more mind-blowing is how this tidal locking affects the planet's weather systems. Winds carrying hot gases from the day side sweep across the planet, and they bring all kinds of strange, alien phenomena like molten iron rains. The planet's lack of rotation makes it a place where extremes collide, and that makes it one of the most bizarre worlds we've ever discovered. Could life survive here? Probably not. But it definitely makes you think about how other planets in the universe might function in ways we can barely comprehend. Iron vapor and condensation. Now, let's dive into one of the most jaw-dropping features of WASP-76b, The rain of molten iron. Yeah, you heard that right. This planet has a bizarre weather system where iron vapor is created on its scorching day side, and then it condenses into liquid droplets on the cooler night side. This phenomenon is a result of the extreme temperature differences between the two halves of the planet. The day side of WASP-76b is a hellish furnace where temperatures are so high that metals, particularly iron, are vaporized into gases. Think of it as a metal mist swirling in the air, made possible by the scorching heat. But what happens when this vaporized iron is carried away by the planet's winds and reaches the cooler, dark side? The temperature drops and suddenly, that vapor can't stay in the air. It condenses back into droplets of molten iron. This creates an unbelievable phenomenon: iron rain. Now, if you were somehow able to stand on the cooler side of WASP-76b, you'd find yourself getting drenched by droplets of molten iron, which is a little bit more than just a rainy day. These iron droplets would be sizzling hot and dangerous, turning everything they touch into a fiery molten mess. The wind and weather systems on this planet are responsible for this process, and it's a bizarre kind of rain that defies everything we know about Earth's water cycle. The science behind it is fascinating, and it raises questions about how exoplanetary atmospheres work. Could there be other planets where different metals rain down instead of water? And what does this mean for planets with extreme conditions? The iron rain of WASP-76b is just the tip of the iceberg when it comes to understanding how wild and strange alien weather can get. Discovery and observations. The discovery of WASP-76b's molten iron rain was a breakthrough that expanded our understanding of exoplanets and their extreme environments. In March 2020, astronomers using the European Southern Observatory's Very Large Telescope made an incredible observation. They detected the presence of iron vapor in the atmosphere of WASP-76b. And just like that, we were introduced to a new world, where conditions are so extreme that metals can exist in gaseous form. This was no ordinary discovery. For years, scientists have been exploring exoplanets and trying to understand how different they could be from Earth. While we've come across many unusual worlds, WASP-76b stood out because of its unique and violent weather system. Thanks to the telescope's advanced capabilities, astronomers were able to analyze the planet's atmosphere in unprecedented detail. They found strong signs of vaporized iron and other heavy metals in the atmosphere, an indication that this exoplanet wasn't just hot, it was a place where extreme conditions could produce strange, almost otherworldly phenomena. But the implications of this discovery go beyond just knowing that iron rains on a planet light years away. It opens up new avenues for studying the weather systems of distant planets, their atmospheres, and how they interact with their stars. The ability to observe such detailed phenomena on distant exoplanets gives us a glimpse into what other extreme worlds might be out there. Worlds where rain could be made of metals, or where the atmosphere could be filled with strange gases. The discovery of WASP-76b's molten iron rain shows us how little we truly know about the universe, and how much more there is to learn. Significance. The discovery of WASP-76b's molten iron rain is more than just an astronomical curiosity. It holds immense significance for our understanding of exoplanetary science and the conditions that exist beyond our solar system. This planet challenges the very notion of what a habitable world could look like. The extreme temperatures and bizarre weather systems are like nothing we've ever experienced here on Earth. Studying planets like WASP-76b helps us understand the limits of planetary conditions and pushes the boundaries of what we consider possible in terms of extreme environments. Beyond the fascination of molten rain and scorching temperatures, there's a broader implication. It raises questions about the diversity of planets in the universe. If a planet like WASP-76b can exist with such harsh and alien conditions, what other kinds of planets are out there? What's the likelihood that there are other worlds with strange weather systems, and could they support different forms of life, or at least show us new ways of understanding how life might adapt in extreme environments? WASP-76. B's discovery also highlights the incredible advances in telescope technology. Observing iron vapor in the atmosphere of an exoplanet wasn't possible just a few decades ago, but now, with instruments like the Very Large Telescope, we're able to analyze these distant worlds with astonishing detail. This kind of research not only broadens our knowledge of the universe, but also shapes the future of space exploration. So, as we continue to look deeper into the cosmos, we're reminded that the universe is vast, full of surprises and far more complex than we ever imagined. And who knows? Maybe this is just one of the many astonishing worlds waiting for us to uncover. So, what do you think? Could we ever encounter a planet as extreme as WASP-76b in our own galaxy? Or are we just scratching the surface of what's out there? Let me know your thoughts in the comments below. If you found this journey through space as fascinating as I did, don't forget to like, share, and subscribe to InnoVision Tech for more mind-blowing discoveries. Thanks for watching, and stay curious about the mysteries of the universe. Over 300 million years ago, Earth's continents collided to form one massive landmass known as Pangaea, covering nearly a third of the planet's surface. This supercontinent wasn't just a geographical marvel, it set the stage for the deadliest era in Earth's history, marked by extreme climates and catastrophic extinctions. Here's a striking fact: the Permian-Triassic extinction wiped out about 90% of marine species. Did you know how this ancient world shaped the future of life on Earth? Formation of Pangaea. The Earth once held a secret so vast and powerful that it reshaped the entire planet, an ancient supercontinent called Pangaea. Around 335 million years ago, the restless movements of tectonic plates forced all the separate landmasses to collide and merge into one colossal landmass, stretching from pole to pole. This wasn't just a simple joining of continents, it was a monumental event that transformed Earth's geography, climate, and life forever. Pangaea's formation created a world unlike anything we see today, a single massive expanse of land surrounded by a global ocean. This immense size meant that the interior regions were isolated from the moderating effects of the sea, leading to harsh, unforgiving conditions. Vast deserts sprawled across the heart of Pangaea, where temperatures soared during the day and plummeted at night, creating a relentless environment that tested the limits of survival. The merging of continents also triggered intense geological activity, with earthquakes and volcanic eruptions shaking the land and spewing clouds of ash and toxic gases into the atmosphere. These dramatic changes set the stage for one of the deadliest chapters in Earth's history. Yet, amid this chaos, life found ways to adapt and evolve, laying the groundwork for future species. Understanding Pangaea's formation is not just about looking back at a lost world, it's about unraveling the forces that have shaped the planet's past and continue to influence its future. This colossal supercontinent was the foundation of an era marked by extremes, survival, and transformation, making it one of the most fascinating and deadly periods in Earth's history. Extreme climate conditions. When a supercontinent as massive as Pangaea dominates the Earth, the climate doesn't just change, it becomes extreme and unforgiving. Far from the calming influence of the oceans, the vast interior of Pangaea was a brutal desert wasteland. Without nearby seas to provide moisture, these inland regions baked under scorching heat during the day, often reaching temperatures that would challenge any living creature. But when night fell, the heat vanished almost instantly, plunging the land into freezing cold. This dramatic temperature swing created one of the harshest environments Earth has ever seen, where survival was a daily battle against nature's extremes. The lack of humidity and rainfall meant that water was scarce, and plants struggled to grow, limiting food sources for animals. Meanwhile, the edges of Pangaea near the coasts experienced more moderate conditions, but the vast majority of life had to endure this relentless desert climate. These extreme conditions also influenced wind patterns, stirring up massive dust storms that could blot out the sun and further disrupt ecosystems. This wasn't just a tough era for life, it was a time that tested the very limits of adaptation and resilience. The climate extremes of Pangaea shaped the evolution of species, forcing them to develop unique survival strategies or face extinction. Understanding this brutal climate helps us grasp why Pangaea's era is remembered as one of the deadliest in Earth's history, where only the toughest could endure the relentless heat, cold, and dryness. Volcanic activity and toxic atmosphere. Volcanoes don't just shape landscapes, they can rewrite the fate of life itself. During the era of Pangaea, volcanic activity reached terrifying heights, unleashing massive eruptions that blanketed the sky with ash and toxic gases. These eruptions weren't isolated events, they were part of a series of colossal volcanic outbursts that released enormous amounts of carbon dioxide and sulfur dioxide into the atmosphere. The result? A deadly cocktail that poisoned the air, acidified rainstorms, and plunged the planet into environmental chaos. This toxic atmosphere choked plant life, disrupted food chains, and created conditions so harsh that many species couldn't survive. Acid rain, born from volcanic gases mixing with moisture, scoured the land and freshwater sources, making survival even more difficult. The volcanic ash also blocked sunlight, cooling the Earth temporarily but causing devastating impacts on photosynthesis, the process plants rely on to grow. This chain reaction rippled through ecosystems, weakening animals that depended on plants and triggering widespread extinctions. The volcanic fury of Pangaea was a key player in the deadliest mass extinction in Earth's history, the Permian-Triassic event, which wiped out a staggering number of species. These eruptions remind us how powerful Earth's internal forces can be, capable of reshaping the atmosphere and life on a global scale. Understanding this volcanic nightmare helps explain why the time of Pangaea was not only a period of great geological change, but also one of the deadliest eras our planet has ever faced. The Permian-Triassic extinction event. Some moments in Earth's history are so catastrophic they kinda redefine life itself, and the Permian-Triassic extinction event was exactly that. Occurring about 252 million years ago, this mass extinction wiped out nearly 90% of marine species and around 70% of land-dwelling creatures, making it the deadliest extinction ever recorded. The causes were, pretty complex, but the supercontinent Pangaea played a starring role. Its massive size and extreme environmental conditions created a perfect storm of stressors. Volcanic eruptions released toxic gases, the climate swung wildly, and habitats shrank dramatically. These factors combined to devastate ecosystems on an unprecedented scale. Oceans became oxygen-poor dead zones, suffocating marine life, while on land, harsh deserts and acid rains made survival nearly impossible. The extinction wasn't just a quick event, it actually unfolded over thousands of years, reshaping life's trajectory on Earth. This catastrophe cleared the way for new species to evolve, including the ancestors of dinosaurs and mammals. Understanding the Permian-Triassic extinction reveals just how fragile life can be when faced with rapid environmental upheaval, and how Earth's systems are deeply interconnected. It's a chilling reminder that even the most dominant life forms can vanish when conditions turn deadly, marking Pangaea's era as one of the most perilous chapters in our planet's story. Lack of coastal habitats. When a supercontinent like Pangaea forms, it drastically reshapes the world's coastlines, and that can mean disaster for countless species. With all the land masses fused together, the total length of coastlines shrank dramatically, wiping out many shallow marine habitats that are crucial for biodiversity. These coastal zones are typically rich in nutrients and shelter, serving as nurseries for countless marine creatures. Without these safe havens, many species lost their breeding grounds and feeding areas, which put enormous pressure on their survival. The vast interior of Pangaea was far from the sea, so most life had to endure harsh, dry conditions, with limited access to water and food. This lack of coastal environments meant fewer opportunities for life to thrive and diversify. The shrinking of these habitats contributed to the mass extinction events that marked Pangaea's era, as species that depended on coastal ecosystems struggled to adapt or faced extinction. It's a stark reminder that geography can directly influence life's chances on Earth. The loss of coastline wasn't just a minor change. It was a major factor in making Pangaea's time one of the deadliest eras in our planet's history. Understanding how the supercontinent's formation squeezed coastal habitats helps us see how interconnected Earth's systems are, and how changes in one area can ripple across the entire biosphere. Gigantic inland seas and their role. Even in the harshest environments, life finds pockets of refuge, and during Pangaea's reign, massive inland seas played that crucial role. These enormous bodies of water formed in low-lying areas of the supercontinent, creating isolated aquatic habitats amid the vast deserts and arid landscapes. Though limited compared to today's oceans, these inland seas became vital sanctuaries for marine life struggling to survive the extreme conditions. They provided not only water, but also more stable climates and food sources, allowing species to persist when much of the land was hostile. These seas also influenced local weather patterns, bringing occasional rains that supported surrounding ecosystems. However, these inland waters were often shallow and prone to fluctuations in salinity and oxygen levels, making them challenging environments that only specially adapted organisms could endure. The presence of these seas highlights the complexity of Pangaea's ecosystems. While much of the supercontinent was deadly, life clung to these watery oases, evolving unique survival strategies. Studying these ancient inland seas offers valuable insights into how life can persist in extreme conditions and adapt to rapidly changing environments. They were lifelines in a world otherwise dominated by harsh deserts and volcanic upheaval, underscoring the resilience and tenacity of life during one of Earth's deadliest eras. Evolution of early reptiles and mammal precursors. Survival during Pangaea's deadly era wasn't just about endurance, it was about evolution and innovation. Early reptiles and the precursors to mammals emerged during this time, developing remarkable adaptations to cope with the harsh environment. These creatures had to face scorching deserts, toxic atmospheres, and scarce resources, which honestly pushed them to evolve new ways to regulate their body temperature, conserve water, and find food. For example, some reptiles developed tougher skin to reduce water loss, while others adapted more efficient respiratory systems to survive in oxygen-poor conditions. These evolutionary leaps laid the foundation for the incredible diversity of life that would follow. Mammal ancestors, though small and fragile-looking, were already experimenting with traits like warm-bloodedness and more complex behaviors, giving them an edge in a world dominated by reptiles. This period was a crucible of natural selection, where only the most adaptable species thrived. The evolutionary innovations born in Pangaea's harsh climate set the stage for future dominance by mammals and reptiles alike. Understanding these early adaptations reveals how life can not only survive but also innovate under extreme pressure, turning a deadly era into a launching pad for evolutionary success. This resilience and creativity in the face of adversity make Pangaea's time a fascinating chapter in the story of life on Earth. Shifting weather patterns and monsoons. When a landmass as enormous as Pangaea dominates the planet, it doesn't just change geography, it rewires the climate system itself. The sheer size of this supercontinent disrupted global weather patterns, creating intense monsoon cycles that brought both devastating floods and prolonged droughts. These monsoons were driven by the extreme temperature differences between Pangaea's scorching interior deserts and the surrounding oceans. During the wet season, powerful winds swept moisture deep into the continent, causing sudden, violent storms that could flood vast areas. Then came the dry season, when those same regions baked under relentless heat, turning fertile lands into barren dust bowls. This unpredictable pendulum of weather stressed plants and animals alike, forcing them to adapt quickly or, perish. The monsoon-driven climate also contributed to soil erosion and altered river systems, reshaping landscapes and habitats. These extreme weather swings made life precarious, especially for species already struggling with limited resources and toxic atmospheric conditions. Understanding how Pangaea's massive size created such volatile weather patterns reveals why this era was so deadly, and why survival required remarkable resilience. It's a vivid example of how Earth's physical changes ripple through climate and ecosystems, shaping the fate of life on a global scale. Geological evidence left behind. The story of Pangaea is etched deep into the rocks beneath our feet, offering a window into a world long gone but never forgotten. Geological evidence, from fossil records to sediment layers and rock formations, paints a vivid picture of the deadliest era Earth has ever faced. Fossils reveal which species thrived and which vanished, showing the dramatic shifts in biodiversity caused by Pangaea's harsh conditions. Sediment layers tell tales of ancient deserts, volcanic ash deposits, and shifting shorelines, helping scientists reconstruct the climate and environmental upheavals of the time. These clues also uncover the timing and impact of massive volcanic eruptions and the Permian-Triassic extinction event, linking geological activity to biological crises. Rock formations, such as glacial deposits found far from the poles, provide evidence of extreme climate swings and the supercontinent's vast reach. Together, these geological records allow researchers to piece together how Pangaea's formation and eventual breakup influenced Earth's climate, ecosystems, and evolutionary pathways. Studying this evidence not only unravels the mysteries of the past, but also offers insights into how our planet responds to massive environmental changes, knowledge that is crucial as we face our own global challenges today. The stones beneath us are silent storytellers, revealing a world where life battled against the odds in one of Earth's most perilous chapters. Breakup of Pangaea and its aftermath. The breakup of Pangaea was not just the end of a supercontinent, it was the dawn of a new world, reshaping Earth's landscapes, climates, and life forever. Around 175 million years ago, the massive landmass began to fracture, driven by the same tectonic forces that once brought it together. This slow but relentless process created new coastlines, ocean basins, and mountain ranges, transforming the planet's geography and opening up fresh habitats. As the continents drifted apart, climates became more varied and stable, allowing ecosystems to recover from the extreme conditions that had dominated Pangaea's era. This breakup paved the way for the rise of dinosaurs, mammals, and countless other species that would come to define the Mesozoic and beyond. The shifting continents also altered ocean currents and weather patterns, fostering greater biodiversity and evolutionary innovation. While Pangaea's time was marked by deadly extremes, its breakup sparked renewal and diversification, proving that Earth's history is a cycle of destruction and rebirth. Understanding this transition helps us appreciate how dynamic our planet is, constantly changing and adapting over millions of years. The story of Pangaea's breakup is a powerful reminder that even the most formidable forces of nature eventually give way to new beginnings, shaping the world we live in today. Thanks for exploring the incredible story of Pangaea with us here at InnoVision Tech. If you enjoyed diving into Earth's deadliest era and want to stay updated on fascinating tech and science topics, don't forget to hit that subscribe button and ring the bell icon so you never miss an update. We'd love to hear your thoughts. Drop a comment below and tell us what amazed you the most or what you want to learn about next. Join our community, and let's keep exploring the future of technology and discovery together. Time isn't as straightforward as we think. Research shows our brains can actually distort time, making seconds feel like minutes or moments seem to freeze, especially during intense experiences. For example, when you glance at a clock, it might appear to stop briefly, an illusion called chronostasis. This reveals that what we call time is deeply tied to perception, not just a ticking clock. Here's the striking truth. Time as we experience it is often an illusion created by our minds. Did you know about this fascinating fact? What is time, really? Time is something we all experience every second, yet its true nature remains one of the biggest mysteries. What if time isn't this unstoppable force flowing outside of us, but instead, a concept created by our minds to make sense of the world? When you think about it, time is how we measure change, sunrises, seasons, aging. But without change, would time even exist? Humans invented clocks and calendars to organize life, but nature doesn't follow a ticking clock, it simply moves through events. This means time might not be a fundamental part of the universe, but rather a tool we use to understand it. Science backs this up. Einstein's theory of relativity revealed that time isn't fixed. It can stretch and shrink depending on how fast you're moving or how strong gravity is around you. This isn't just theory. Astronauts in space experience time slightly differently than we do on Earth. So time isn't the same for everyone, everywhere. It's flexible, not absolute. This challenges everything we think we know about the past, present, and future. Maybe time is less about clocks and more about perception, a mental framework that helps us navigate life. If time is an illusion, then what does that mean for how we live? Could it mean that the moments we experience right now are all that truly exist? Understanding time this way changes how we see our lives, pushing us to focus on the present, instead of worrying about what's next or what's behind. Time might be a trick our brains play, but it's a trick that shapes our entire reality. Time as a human construct. Time as a human construct is a fascinating idea that flips how we usually think about our daily lives. We often assume time is this universal, unchanging backdrop against which everything happens. But in reality, time is a system we created to bring order to the chaos around us. Think about how different cultures have developed various calendars and ways to mark time. Some based on the moon, others on the sun, and even seasons. None of these are natural clocks. They're tools invented to help us coordinate activities, plan for the future, and remember the past. Nature itself doesn't follow a strict schedule. Rivers flow, trees grow, and animals live their lives without consulting a clock. This means time, as we know it, is more about human convenience than an absolute cosmic rule. Our brains are wired to perceive events in a sequence, which helps us survive and make decisions, but this perception doesn't necessarily reflect how the universe operates. When you realize time is a human-made framework, it opens up a new way of looking at life. One where the pressure to beat the clock or save time might just be a habit, not a necessity. This perspective encourages us to slow down, appreciate moments as they come, and understand that the ticking clock is more about us than about the world itself. Time might be a clever invention, but it's also a reminder of our creativity and need for structure in an otherwise unpredictable universe. The physics of time. Einstein's theory of relativity completely changed how we understand time. Before him, time was seen as a steady, unchanging river flowing at the same pace for everyone, everywhere. But Einstein showed that time is much more flexible. It can bend and stretch depending on how fast you're moving, or how strong gravity is nearby. This means that two people experiencing different speeds or gravitational forces can actually experience time at different rates. For example, astronauts orbiting Earth age just a tiny bit slower than people on the surface because of these effects. This isn't science fiction, it's been proven by precise experiments. The idea that time is relative shatters the old notion of a universal clock ticking the same for all. Instead, time becomes something intertwined with space, forming a four-dimensional fabric called space-time. When objects move or have mass, they warp this fabric, causing time to behave in surprising ways. This discovery forces us to rethink what time really is. It's not an independent entity, but a dimension affected by the universe's conditions. Understanding this helps us see that our everyday experience of time is just one version of many possible realities. Time's flexibility at cosmic scales hints that what we perceive as fixed and absolute is actually fluid and dependent on perspective. This revelation is one of the most profound shifts in science and philosophy, inviting us to question how we live and perceive existence itself. Time dilation explained. Time dilation is one of the most mind-blowing consequences of Einstein's relativity. It means that time doesn't tick at the same speed for everyone. If you were to travel close to the speed of light, your experience of time would slow down compared to someone standing still on Earth. So, while minutes might pass for you, hours or even years could pass for others. This isn't just theoretical, it's been confirmed by experiments with fast-moving particles and precise atomic clocks on airplanes. Time dilation also happens near massive objects like black holes, where gravity is so intense that it warps space-time dramatically. For someone falling into a black hole, time would seem normal, but to an outside observer, their time would appear to slow down and almost freeze. This phenomenon shows that time is not a universal constant, but something flexible and relative to your position and speed. It challenges the everyday assumption that time flows uniformly for everyone. Instead, time becomes a personal experience, varying with circumstances. This idea opens up fascinating possibilities about how we understand aging, travel, and even the nature of reality itself. Time dilation reveals that the universe is far stranger and more complex than our everyday experiences suggest, making us question what we really mean when we say time. The arrow of time. The arrow of time is a concept that explains why we experience time as moving forward, never backward. This directionality is closely linked to entropy, which is the measure of disorder in a system. According to the second law of thermodynamics, entropy always increases over time in an isolated system. Think of it like a messy room that naturally gets messier unless you clean it up. This increase in disorder gives time its arrow, pointing from past to future. Without this tendency toward greater entropy, time might feel reversible, like a movie you can rewind and play forward again. But because entropy grows, events unfold in one direction, creating the flow of time we experience. This concept connects the physical laws of the universe with our psychological sense of time passing. It also explains why memories exist only of the past, not the future, and why causes come before effects. The arrow of time shows that time's passage is deeply rooted in the fundamental workings of the universe, not just in human perception. Understanding this helps us grasp why time feels so real and irreversible, even if its nature is more complex than it seems. Memory and perception of time. Our perception of time is deeply tied to how our brains process memories and experiences. We naturally divide life into past, present, and future, but this may be more about how our minds organize information than about time itself. Memory creates a sense of continuity, allowing us to remember what happened and anticipate what might come next. However, the present moment, the now, is fleeting and constantly changing, making it hard to grasp fully. Neuroscience shows that the brain constructs this flow of time by linking events and sensations, giving us a sense of progression. This means that what we experience as time passing could be a mental narrative rather than an external reality. Different people can perceive time differently depending on attention, emotions, or age, which further supports the idea that time is subjective. For example, moments of fear or excitement can feel like they stretch out, while routine tasks seem to pass quickly. This subjective experience of time challenges the notion of time as a fixed, objective dimension. Instead, time might be a personal, flexible experience shaped by how our brains interpret the world around us. Understanding this can help us become more mindful of how we live and appreciate the present moment more fully. Quantum mechanics and time. Quantum mechanics radically challenges our everyday understanding of time, revealing a reality far stranger than we imagine. At the tiniest scales, smaller than atoms, particles don't follow a straightforward timeline. Instead, they can exist in multiple states simultaneously, a phenomenon known as superposition. Even more puzzling is entanglement, where particles influence each other instantly across vast distances, defying classical ideas of cause and effect. This blurs the linear flow of time we take for granted. Some interpretations of quantum physics suggest that time might not be a fundamental dimension, but an emergent property arising from deeper, timeless laws. In this view, the distinctions between past, present, and future become less clear or even meaningless at the quantum level. What we experience as time could be a large-scale illusion created by the complex interactions of countless particles. This challenges not only physics but also our understanding of reality itself, pushing scientists and philosophers to rethink existence. Is time truly a basic part of the universe, or just a useful concept humans use to make sense of their experiences? This question remains one of the most profound in modern science, inviting us to explore the mysterious fabric of reality beyond everyday perception. Time in relativity versus everyday life. In our everyday lives, time feels fixed and absolute, a steady rhythm guiding our routines. However, physics reveals a far more complex picture. According to Einstein's theory of relativity, time is flexible and depends on your frame of reference, how fast you move or how close you are to massive objects like planets or stars. While these effects are profound in cosmic settings, they're incredibly subtle at human scales, which is why we rarely notice them in daily life. This creates a fascinating gap between scientific reality and our everyday experience. We rely on clocks and schedules that seem rigid and universal, but the universe operates with a fluid, relative concept of time. This contrast highlights that our perception of time is shaped more by practical needs than by cosmic truths. Recognizing this can deepen our appreciation for the complexity of time and encourage us to question long-held assumptions. Instead of seeing time as a fixed backdrop, we can start to view it as a dynamic, ever-changing part of the universe, one that challenges how we organize our lives and understand existence itself. This shift invites us to think beyond the clock and embrace a more nuanced understanding of reality. Philosophical views on time. Philosophers have long debated the nature of time, presenting two main views that challenge our everyday understanding: presentism and eternalism. Presentism holds that only the present moment truly exists. Past and future are illusions, no longer or not yet real. This aligns with our intuitive experience of time flowing, where the present continuously replaces the past. In contrast, eternalism argues that past, present, and future all exist simultaneously, like points on a vast landscape. Our sense of now is just a moving point of awareness within this timeless block. Eternalism finds support in physics, especially Einstein's relativity, which treats time as a dimension similar to space. These perspectives suggest that time might not be an external objective reality, but a mental construct shaped by how we perceive existence. This debate invites us to rethink our relationship with time, questioning whether what feels real is only a part of a larger, more complex universe. Understanding these views helps bridge philosophy and science, deepening our grasp of reality's true nature. Living beyond the illusion. If time is truly an illusion, it fundamentally changes how we live our lives. Instead of being slaves to clocks, deadlines, and schedules, we can shift our focus to the present moment, the only moment we genuinely experience. Letting go of the idea that time rigidly controls every second opens the door to a more fluid, mindful way of living. This mindset encourages us to fully embrace experiences without rushing toward the future or getting stuck in the past. It suggests that true happiness and meaning come from being present, not from chasing after time. Recognizing time as an illusion can relieve the stress and anxiety tied to its relentless passage, helping us appreciate life's moments as they unfold naturally. Rather than prisoners of time, we become mindful navigators, finding peace and fulfillment in the now. This shift transforms how we relate to ourselves, others, and the world, making life richer and more meaningful. Embracing the present moment allows us to live more deeply, free from the constraints of an imagined timeline, and opens a path toward greater awareness and contentment. Thanks for watching this deep dive into the illusion of time here on InnoVision Tech. If you enjoyed exploring these mind-bending ideas, don't forget to hit that subscribe button and ring the bell icon so you never miss our latest videos on cutting-edge science and technology. We'd love to hear your thoughts. Drop a comment below and share what fascinates you most about time or any questions you have. Together, let's keep pushing the boundaries of knowledge and innovation. Stay curious and see you in the next video. What if I told you that for just 1 second, everything stopped? Not just your clock, not just your phone, but time itself, the entire universe frozen in place. No movement, no sound, no light, just complete stillness. Sounds insane, right? But here's the real question. What would actually happen if time stopped for just 1 second? Would you feel it? Would the world change? Or would we never even know? Stick around, because what you're about to hear will make you question everything you thought you knew about reality. Are you ready to dive into the impossible? Let's find out. The nature of time and perception. Imagine if time suddenly stopped, just for a single second. Sounds harmless, right? But hold on, because time isn't just a ticking clock. It's the very thing that keeps reality in motion. From the way we breathe to the way light travels, everything is governed by time. But what if, for a brief moment, time completely froze? Would we even notice it? Well, here's the crazy part. You wouldn't. Your brain, like everything else, relies on time to function. Every thought, every memory, every movement you make depends on time moving forward. If time paused, so would your neurons. Your brain wouldn't even get the chance to register that something strange had happened. Imagine blinking, but in that brief moment, everything, your heartbeat, your thoughts, even the air around you, completely stopped. And yet, when time resumed, you'd continue as if nothing had happened. Think about it like a video game freezing for a second due to lag. The game doesn't realize it's frozen, it just picks up where it left off. the same would happen to you. But here's a fun twist. If time stopped, would light stop too? That means, even if your eyes were open, you wouldn't see anything. The entire world would be trapped in absolute darkness for that one frozen second. And if we go deeper, this raises an even wilder question. If time stopped, but you somehow remained aware, would you feel like you were stuck in eternity? 1 second might stretch into an infinite abyss. Spooky, right? Luckily, your brain won't let you experience that. So, in reality, the biggest mystery of all is, did time ever stop before, and if it did, how would we even know? Physical implications of a time freeze. Let's say time halts. You're in the middle of drinking coffee and suddenly, BAM! Time stops. The coffee mid-air freezes, the steam rising from the cup, suspended like an invisible sculpture. But the real question is, what happens on a deeper level? First off, all movement in the universe would come to a standstill. Atoms would stop vibrating, which means heat would cease to exist. Every object from your body to the sun would instantly drop to absolute zero. But here's the twist, you wouldn't feel cold. Why? Because you wouldn't even be able to process the change. Your nerves wouldn't work, your brain wouldn't function, and even your very thoughts would be put on hold. Then, there's light. Light moves at 299,792,458 meters per second. But if time stopped, light wouldn't move at all. That means the entire universe would be trapped in absolute darkness. Even if the sun was shining, its rays wouldn't reach your eyes until time resumed. Imagine someone flipping a switch and shutting off all light instantly. Except in this case, it's not just the lights in your room, it's every photon in existence. And here's where it gets weirder. What about air? Normally, air molecules zip around, allowing you to breathe. But if time froze, they'd stop moving too. That means for that 1 second, oxygen wouldn't reach your lungs, but don't panic. You wouldn't suffocate because, well, your lungs wouldn't be working either. Time would unfreeze, and you'd continue as if nothing happened. So, the next time you take a deep breath, look at the sky, or feel warmth on your skin, just remember, time is what makes it all possible. And if it ever stopped, even for just a second, the entire universe would hold its breath with you. Biological effects on living organisms. Let's talk about life itself. Your heart, your breath, your very existence. Everything in your body depends on time moving forward. But what happens if time stops for just 1 second? Would you feel it? Would it harm you? Here's the surprising answer: no, you wouldn't feel a thing. That's because the biological processes inside you are just as tied to time as everything else. Your heart beats, your blood flows, and your cells divide. All of these depend on time's steady movement. If time stops, so do you. It's like hitting the pause button on a movie. Nothing changes, but nothing moves either. Your body would be frozen in place, your brain would stop thinking, and even your sense of awareness would be suspended. And here's the freaky part. If everything about you stopped, you wouldn't even know time had paused in the first place. Your body wouldn't age, your cells wouldn't decay, and technically you wouldn't even be alive in that moment, but once time resumes, your body picks up right where it left off, as if nothing ever happened. But here's where things get really strange. Imagine you're blinking right when time stops. Your eyelids would freeze mid-motion, leaving your vision locked in place. If you were walking, your muscles would be frozen in action, defying physics for just a split second. And what about people in mid-sneeze? Would they be stuck with the world's longest ah-chew? The truth is, time's flow is what keeps all living things functioning. If time ever stopped, even briefly, life itself would hold its breath, waiting for the next second to arrive. And yet, because we experience time so seamlessly, we'll never know if it's already happened before. Technological and mechanical consequences. Now let's talk about the world around us. Machines, vehicles, the internet, and all the technology we rely on daily. If time stopped, would your phone glitch? Would planes fall from the sky? Would your favorite video game freeze mid-frame? The short answer, yes, but only for that brief second. Every piece of technology we use operates based on time. Clocks tick forward, computers process data, and electricity flows through circuits. All of it requires time to function, so if time stopped, everything electronic would pause too. Your phone screen would freeze mid-scroll, your Wi-Fi would halt, and even the electrical signals running through power lines would be suspended. Now, here's a mind-blowing thought. Cars, planes, and trains all rely on movement through time. If time stops, a speeding car wouldn't crash, because it wouldn't be moving at all in that moment. A plane in midair would hang in place, defying gravity for that 1 second. The entire world would be a frozen snapshot, paused in perfect stillness. And what about artificial intelligence? Could a supercomputer realize that time had paused? Not a chance. Just like our brains, AI needs time to process information. If time stops, it stops thinking too. It wouldn't detect the pause because, in its reality, there was no pause. The moment time resumes, it continues processing as if nothing happened. And here's where it gets even wilder. Would digital timekeeping devices skip a second, or would they stay perfectly accurate? Since they rely on electrical pulses that measure time, a 1-second stop might throw them off ever so slightly. But in a world where time is back on track, who would even notice? So the next time your computer lags or your phone screen freezes for a second, just ask yourself, what if time actually did stop for a second and we all just missed it? Psychological and philosophical considerations. Alright, let's get deep for a second. If time stops, do we stop existing? Think about it. Our entire experience of reality is tied to time. Every thought, memory, and feeling happens in a sequence. But what if time itself was put on pause? Would we even be aware of it? Here's the trippy part. You wouldn't even realize that time had stopped. Your consciousness, your awareness, your very sense of self would be frozen, just like everything else. It's like someone pressing pause on the universe. The second time resumes, everything picks up where it left off, and you have no clue anything ever happened. It's a bit unsettling, isn't it? Now let's push this even further. What if time has already stopped before? Maybe it pauses for a second every few thousand years and we just don't know it. Maybe right now, time has stopped, and you're frozen in place, unable to perceive the stillness. And the moment it resumes, well, you're right back to reading this sentence as if nothing happened. Then there's the ultimate question. If time stops, does reality still exist? Time and space are deeply connected, meaning if time ceases, does the universe even remain? It's a classic philosophical paradox. Does reality require time to exist, or could the universe just hang in place, waiting to move again? And if we go even crazier, what if time isn't real at all? What if time is just a human-made construct and the universe moves in ways we can't even comprehend? Maybe we're living in a cosmic illusion where time is just an illusion of motion. If that's the case, then stopping time wouldn't just freeze the world. It might break the very foundation of reality itself. 1 second. That's all it would take to change everything. Or maybe it already has. Theoretical physics perspectives. Now let's get scientific, because if anyone can explain what happens when time stops, it's physicists. But here's the kicker. According to physics, time stopping shouldn't even be possible. Time isn't just a background setting, it's woven into the very fabric of the universe, tied to space itself. Stopping time would mean disrupting space-time, which could have insane consequences. For starters, Einstein's theory of relativity tells us that time is relative. It speeds up or slows down depending on gravity and motion. But completely stopping time? That's next level. If time froze, space-time itself would be affected. Would the universe continue existing in a paused state? Would everything collapse into chaos? And let's talk about quantum mechanics, the science of the tiniest particles. On a quantum level, particles are always in motion, constantly shifting and vibrating. If time stopped, these particles would freeze in place. That means no atomic activity, no light movement, no energy transfers, literally nothing happening. It's a complete shutdown of the universe at its most fundamental level. But wait, it gets weirder. Some physicists argue that time is just an illusion. According to certain theories, time isn't something that moves. It's just a way we perceive changes in the universe. If that's true, then stopping time wouldn't actually do anything, because there's nothing to stop in the first place. Mind blown yet? So let's sum this up. If time stops everything, energy, motion, thought, light ceases. But since time itself is part of space-time, freezing time might be impossible without breaking reality itself. And if it ever did happen, we wouldn't even know. So the real question is, what if time has already stopped, but we're just living in its resumed state? What if we're part of a cosmic play button being pressed over and over? Maybe time itself is the biggest mystery of all, and we're just along for the ride. And that, my friends, is the mind-bending reality of time. Did time ever stop before? Would we even know? The universe is full of mysteries, and this is just the beginning. If you love diving into mind-blowing theories like this, make sure to hit that subscribe button and turn on notifications so you never miss a video. What do you think would happen if time stopped? Drop your thoughts in the comments. This is InnoVision Tech, and I'll see you in the next one.